All right, so everything I'm about to show you is up on Google Classroom. Open it up for me. It's under the circle unit. Some of you guys stay in the stream. That's fine, but it's review for quiz 2. All right, review for quiz 2. I went yesterday and did a mass revision of it. And this is no joke now. All right, this is as good as it's going to get. So here's what my plan is right now. I am just going to go all through every single fact that I have for you for the quiz. Do you know it or not? And if not, I'll go to somebody else and we'll review it. Okay? So reminder, right off the bat, quiz covers days 4 through 9. That's where you want to look in your packet if you want to review, look back at your notes. Days 4 through 9. All right, kids, let's see what we know here. Some of you, this is going to be an avalanche, and you're just going to pop right through and just be like, let's go, I'm ready to roll. And some of you are just going to be putting a little pinky up through the snow, being like, help, 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 I need help by Monday. All right, so this is why I'm doing it. You need to walk out that door today knowing what do I need to know and how good am I before Monday. All right, here we go. Top left-hand corner. I want to know what type of angle is A, what do I call it, and how to find it. Okay, what type of angle is A, and how do I find it? Let's roll. Shara, what type of angle is it? It is an inscribed angle. Great job. And how would you find angle A in this one? There you go. Half the measure of arc CB. Perfect. Good start. We're off on a good note. That's an inscribed angle, and I find it by taking half of arc CB. And if any time, raise your hand, guys. This is your review. Raise your hand if you have any questions. Next up, angle J. What do you know about it? And then we'll write the fact Y underneath. What do I know about angle J up there? Angle J. And yes, please assume that these black dots are the center. Okay, please assume these black dots are the center. What do I know about angle J up there? 17. Dylan, what do you know about it? Darn right it is. It's a right angle. Now, hey, I am going to put a proof, guaranteed I will have a proof on there on Monday. So if you put a right angle somewhere, you need to tell me why it's a right angle and the reason. So let's write underneath here why angle J is a right angle. All right, what would be the fact I use to have a right angle up here? Where are we going? Nope. Let's try here. Okay, Jared, what type of angle is J, first of all? Okay, so here's how I'm going to start it. Inscribed angle. Drawn to, Jared, back to you. Where's angle J drawn to? What's that called there? Good job. Drawn to a diameter is a right angle. So that's what's going in my reasons column if I ever need to say that's a right angle for a proof. Inscribed angle drawn to a diameter is a right angle. Guys are on fire today here. 2 for 2, huh? Next diagram, bottom left. Don't tell me vertical angles are congruent. I want to know something true about angles A, B, C, and D. Anything that you know is true, what could you mark on this diagram that's true? All right, other than vertical angles. I'm looking for circle facts now. All right, I don't want vertical angles congruent. Give me something about angles A, B, C, or D that you know are true and you can mark on the diagram. All right, let's start here. Anything you know is true here? I'm trying to get to other people. Alyssa, anything? BD is a diameter. Good. I'm looking for angles, though. Angles. What type of angle is B? What type of angle is A? Do you notice where they're both drawn to? They are, but where specifically? Look at angle B. Tell me what arc angle B is drawn to. Angle B, right here, right? Angle B. What arc is it drawn to? Follow it. What arc is it drawn to? CBD. Ready? What arc's in between it? CD. Okay. Look at angle A. What arc is in between it? What'd you just notice? Both of them are drawn where? The same one. So they have to be? There you go. A and B are congruent. So angle A congruent to angle B. Or we could have said the same thing about angle C congruent to angle D. You put that in your proof on Monday. Reason will be inscribed angles. Going back to you, Alyssa, to finish this. Where are they drawn to? Same arc. Inscribed angles drawn to the same arc are congruent. Woo. All good. All good. Next, last diagram on this page. Tell me something about these angles. Tell me something about pairs of these angles. G, K, I, H. I know all of them add to 360 because it's quadrilateral. I don't need to know that. I'm looking for a little circle fact, though. All right, what do I know? That's a quadrilateral inside a circle. What do I know? Anything about the angles and their relationships? Any angle relationships we know about? Zoli? I have an inscribed quadrilateral.
Angle G equal to angle I.
Not equal to each other. Not congruent. They do have a relationship, but it's not being congruent to each other. G and I have a relationship, and so do H and K. Not being equal, though. They are supplementary. There you go. They do add to 180 degrees. All right. I am not going to write down a reason because I do not see you using this in a proof. I would see you using this in an algebra question, where you just take the two and set them equal to 180. So we're not going to write down a reason here. All right, good so far. That's just the first page, kids. Just the first page. Questions? All right, let's keep rolling. Let's see what else you know. Add to this diagram on the top left. Add to it. Add to it, please. What markings could you put on this diagram that you know are true? And yes, that black dot is the center. What else can you write on this diagram that's true? Get this on. There we go. Lauren, what else is true? Yep. That's a right angle on both sides. You would definitely put that in a proof somewhere, maybe. So let's talk about what the reason would be. Lauren, going back to you, what's that green line? Radius. Yep, here we go. Radius drawn to, what's that green point called, Lauren? Good. Perfect. Radius drawn to point of tangency is a right angle. Good job. Let's keep going. Next diagram. I'm not a big fan of this. A little embarrassed by this diagram myself, but G, K, and I are where they intersect the circle. Okay, those are your points of tangency. That's where they intersect the circle. What's true up here? There's actually three things that are true, but I only want one. What's true about this diagram? Give me something that's true. You could add on to it. What's true up here? Bryson, anything that's true?
It has tangents on the circle.
Yep, I'm looking for a specific something about these segments up here. Got your packet on you? Okay, let's get your packet because you looking this up will have you remember it by Monday. I think it's day 5, tangents. Look up day 5, tangents, and you let me know what's true on this diagram here. Day 5, tangents. I think we did day 5, tangents, right? Yep. We did a proof to prove this theorem too.
Oh, is it a tangent segments drawn to the same point?
Okay, now take that fact and look at the diagram now. Give me two that are congruent then.
HF and JF.
Not the full ones. You're just the segments part. Just the segment part. Not the full ones are HF and FJ aren't congruent. It's the segment part. So let me start out. HG. That's a tangent segment. Should be congruent too.
Oh, GF and KF.
Whoa. HG. You just read that theorem again. Read that theorem again. You said two tangent segments drawn where?
To the same point.
Okay, so this one's drawn to H, so it's going to be congruent to the other one drawn to H, which is what?
HI.
There you go. Those two are equal. Okay? We called this the party hat theorem. All right, to help you guys remember, we called this the party hat theorem. Coming up. Also, two other pairs equal. Ready? FG and FK, along with KJ and IJ. Those are equal. And again, Bryson said it a couple times already, but if we ever need to use that in a proof, tangent segments drawn to the same point are congruent. Anything so far? We haven't even gotten to the angles yet. These are just some circle facts. We haven't even gotten to all the different types of angles we've been going over. All right, let's hit that up. If an angle is formed inside the if an angle is formed inside the circle, there's three types. Okay, three types of angles can be formed inside a circle. Let me start with this diagram, an angle KPN. I want to know its name and how to find it. Okay, KPN. What do I call it? I know it's inside, but what do I call it and how do I find it? All right, what did we call that angle up there? There we go. All right, Dylan. We'll get there. Lexi, what do I call that angle? It's a floater angle, right? How do I find a floater angle? What's the rule here? Use the arc names here too for me. How do I find that floater angle?
So you do KN.
Okay, hold on. KN and, yep, keep going.
LM.
And LM, and what do I do to the two?
You subtract.
Ooh, that's the angle on the outside. If it's a floater, I add them, yep, and divide by 2. So floater angle, I take the connected arc, add it to the vertical angle's connected arc, and divide by 2. Floater angle. Second time we've gone over this, but I don't care. Repetition's good. What type of angle is angle A up here? Angle A, what are we looking at? Drew, what do we call that? How do you find it? Which would be what here? Half of? CB. Good job. And the last type of angle you could find in a circle, if it's not floater or inscribed, could be I'm going to call that an O there. Sorry. Should have put that on there. One job. If it's not floater, it's not inscribed. It could be angle ROS, which we refer to as going all the way back here. Stellan, what do I call that? Central. How do you find it? Yep. So in this case, it would be equal to the measure of? So we have three types of angles inside. Well, if it's not inside, it could be outside. And when it's outside, we don't care how it's formed. There's no other questions. Once you notice angles on the outside of a circle, there's only one way to find it. So how do I find angle Q there on the outside? Angle Q. What's the rule for that one on an angle on the outside? Cormac?
US minus TR divided by 2.
Good. The arcs in between get subtracted. US minus arc TR subtracted. divided by 2. Angle on the outside, we subtract. A floater, we add them. Good work, good work. What if it's not inside? What if it's not outside? Then it must be a tweener, right? Half and half, as we called it yesterday. Half and half. All right, so let's look at this tweener angle over here. Angle XWV. That tweener angle right here, XWV. There are 2 types of tweener angles. This is the first one, which, let me just ask somebody a quick question here. We'll get the people here. It's going to be a while. There we go. Henry, welcome back. Do you know this or not? Probably by now. Whoa. This is what's XW? And what's VWY? Okay, everyone, before I ask Henry to finish this is an angle, a tweener angle formed by a chord and a tangent. Chord and a tangent. We have a rule for that one. This is the tweener angle we have a rule for. Do you know it, Henry? Half the arc. Good. So I'm going to take half of arc XZW. The tweener that has a rule is an angle formed by a chord and a tangent. Which tweener angle does not have a rule? Angle CBA up here. Because it's formed by a what and a what. This one does not have a rule. I might just refresh here and just keep going. This is fun. Just want to hear from, there we go. Brendan, ready? What's CB?
Chord.
You remember what we called DBA yesterday?
Secant.
Okay, this one does not. The tweener that's formed by a chord and a secant, no rule. But I'm still going to have you find it. Anybody remember how to find that one? Take your, what's right next to it? What type of angle is right next to it? Inscribed angle. Take your inscribed angle, find it, and it's supplementary to that tweener angle. Yep. So ready? Tangent chord tweener, we're good. We got a rule. Chord secant, no rule. No rule. So that's all your angles in a circle, those last 3 slides there. That's all the angles in a circle I could have you find. Next page here. I wrote down a couple more facts that we've done that could be used in a proof. If the arcs are congruent, so are central angles, inscribed angles, and chords. Look at number 4. I didn't write this one out because I wanted to make sure we were good there. What's happening on number 4? If you have this diagram, what is happening? What markings could you put on the diagram too? Let me put it that way. What markings could you put on there? All right, that red dot is the center. The red dot is the center. What is true about this diagram up here? If I have this going on. Let's talk. There we go. Well, we're going to keep grinding here, guys. As annoying as this is. Bailey, any idea what's going on up there? What's AC?
AC is a diameter.
Yep, and what's DEB? That's a what?
Chord.
And I put that right angle symbol on there, so that tells me they're perpendicular to each other. So if I have a diameter perpendicular to a chord, chord is getting
Bisected?
correct. Okay, everyone, if I have a diameter perpendicular to a chord, the chord is getting bisected. Diameter perpendicular to a chord. Bisects the chord. All right, there it is. That's everything. I got a couple other things I want to do with you, but That's everything. How deep is that snow right now, Anya? Can you breathe? Anything you want to ask? I have a couple other little things, but that's everything for circles we've done in days 4 through 9. All right, one thing I want to go over with you. A little algebra that may come up, and I don't want you to be freaked out, and I don't want you to just totally drop the ball here. This might be part of your calculations on Monday. How are you going to handle it? If somewhere in any equation you have x minus 3 all squared, and you need to simplify that out, how's that getting simplified? Because I don't want this. Oh, it's x squared minus 9 or plus 9. That's not how we roll in here. That's not how you rolled last year anyway in Algebra 1. If that is part of an equation tomorrow, how do you handle it? Go ahead, Stellan.
Distribute everything into everything.
So x minus 3 twice. And now we start multiplying. Okay, now we start multiplying. I'll do it here with you. So we got x and x squared, x and negative 3x, and then you distribute the negative 3. Minus 3x. Make sure you do it one more time, and that'll give me plus 9. And then combine your like terms. I just wanted to at least give you a shot, because I would feel pretty bad on Monday if you knew the circle facts, what to use and everything. It was just your algebra that you got points off. I'd feel pretty bad for that. So I want to at least give you a heads up. All right, before we leave Google Classroom, I want you guys to go back to get off this for me, please. And I just want you guys to see that I posted king size circle problems on Google Classroom. All right, if you go back to Google Classroom, I posted not just only king size problems, 46 of them. All right, 46 if you need to practice. All the answers are after the 46. All right, so you got 1 through 46, and then the answer started here. I'm sure one of them is going to be on the quiz, by the way. One of them I'm sure will be there, because that's where I get all my king size problems from. 1 king size, 1 proof. That's the only thing I'm going to tell you about the quiz. 1 king size circle question and 1 proof. I can guarantee that. The rest, let's see what you got. Can you go to your packet now for me, please? Let's go to your packet. I do want to do 1 question from the review, just to make sure to see how we're doing. Go to number 7 on the review. You guys can start labeling your diagram with the givens, and then we'll talk. All right, we're ready. Hopefully we're not looking at parts A through E. I think that's just going to frustrate you sooner or later. What are you going to try to do on Monday before you start any of these king size circle problems? Try to find all the arcs. Usually you could. There's a couple instances where king size problems you can't find every arc, but most of the time you can, and in this problem we can. So let's try to find all the arcs here on number 7 before we start A through E. We know one arc 60, second arc 80. Anything else up there that could help us find another arc? Anything up there that you know about that could find another arc measure? Stellan, what are you thinking 75. Here? All right, let's talk about that 75-degree angle I gave you. Inside? Outside? That's a tweener I gave you, isn't it? And it's a special tweener because it's formed by, what's EA? chord and BAF a tangent. That's one we have a rule for. So this is a tweener angle we have a rule for. So if the angle's 75, what can I do with it to find the arc in between? Double it. There you go. Arc EA, $1.50. All right, know my rule. Done. That's 150. And I think DC now. Let's go. If you tell me I have all arcs but one, you should be able to find that one. All right. If you're like, wait a sec, I have one arc left. If you have one arc left, let's subtract the rest from 360 then. And we're getting arc DC to be 70. 70 degrees. All right, now we can go to work. Your chances for success increased a little bit. All right, part A, done already, right? Done, DE. What do we have, 150? Or AE, sorry, AE, 150. All right, I'm gonna turn it over to you guys. Everyone's fair game now. Angle DOC, inside, outside, tweener. That's all I wanna know. That's how I start my questioning. Angle DOC, inside, outside, tweener. Boom, Stellan, inside, outside, or a tweener? Inside, so it's got to be one of the three types, central, inscribed, or floater. Okay. And how do we find the central again? Done. Also recommend putting it in the diagram once you find it. Okay, things get a little tricky now. That was pretty straightforward, part A and B. Now it gets a little tricky. OAB. OAB. Look at that angle, everyone. Let's see if you recognize what's going on there. OAB. Do we recognize by now what's going on there? Some of you may say that's a tweener angle, but I disagree because OA is a radius. You need a chord and a tangent, not a radius and a tangent. So that's not a tweener, sorry. And in fact, that's not any angle we've ever talked about. But it is... we have talked about it. It's just not one of those inside-outside tweener angles. All right, here you go. Anything you know what's going on there at AOB? Bailey, anything? They are. Why? What's OA? And what's BAF? And when those two meet at the point of tangency, we form a right angle. Not too bad when we know those facts. Not too bad. Whew, all right, I don't know if some of you guys might go nuts on this one. Part D, OAE. Look at that bad boy. OAE. I want to first just, that is not inscribed. Why is it not inscribed? What's OA again? That's a radius. Inscribed angle has two chords as their sides, right? Two chords. So again, AOE is not anything we've talked about. So maybe a circle fact won't be used here. How about some geometry maybe? All right, OAE, it's not anything we've talked about, but I'm still asking for it. Talk me through it. Talk me through it. Ooh, here we go. Henry, you want to talk me through this bad boy?
75, and then the right angle on the other side, so 15.
Yep. There's a couple different ways you could do it. These three angles, the 90, the 75, and the one we're looking for, that forms a straight line, 180 degrees in this class all year. Or you notice that we just put a 90 here from the last part. That means right next to it has to be a 90-degree angle. So either 180 minus 90 minus 75 or 90 minus 75 will get you there. And that'll be a 15-degree angle. Notice no circle fact there. Just plain old school unit 1 or 2 geometry. Ooh, you ready for DCO? This is the toughest one, I think, of all of them. And this is why I'm doing the problem with you. DCO. It's definitely inside, but it's not central. Some of you may think it's inscribed, but again, I need chords, and that's not a chord, CO. It's definitely not a floater. Still asking for it, though. Still asking for it. Let me give you a little boost here if you need it. What's DO and OC again? They're radii in the same circle. What do you know about them? They're congruent. What type of triangle did we just make? And there it is. Go. We just made an isosceles triangle. That was a little tough one there, noticing that he had isosceles triangle there. So 180 minus 70 divided by 2. The answers to these are on page 44, so please check your work as you're going. I have given you plenty of practice. You have a ton of questions in your packet, and I just showed you where 46 king-size circle problems are on Google Classroom. I'll be here after school today.